Hi, this is a short presentation about DynuST and DynuStudio mapping and visualization capabilities. A total of 4 categories of mapping and visualization capability will be presented. First, let's take a look at link performance. Then we'll look at corridor performance, trajectory performance, and some of the 2D, 3D animation visualization capability on Google Earth. First of all, I would like to look at a set of performance on the link that can be displayed from individual, system, and scenario comparisons. So we know a network consists of many links, and a lot of time we would like to take a look of the performance on specific links, either one link or a set of links. Let's first take a look. There are a range of different link level statistics can be displayed, and in the interest of time, we'll go through only a selected number of them. Volumes, density, travel time, flow rates, left-hand flow, and average volume and queue length. These are all the typical statistics that can be displayed. Let's take a look at the average density. In DynuStudio, the graphical user interface, this is a window typically a user will be using to examine a variety of different scenario and the statistics. Let's take a quick look on this window. On the upper left corner, there are a number of menus where you can specify the interval of which the animation has been displayed or the data been aggregated. Some obvious options are exporting the result to a CSV file can be used for importing to other tools like Excel. There's a pull-down menu that you can select a number of different performance measures. And typically, in typical graph like this is in terms of the time. So if we perform a 24-hour simulation assignments, this is in terms of hours, and 15-minute interval is the current aggregation intervals. You can do 1 minute, 5 minutes, even to an hour by selecting the interval menu. The y-axis is the density. In this plot, we are showing the density. So the density is in terms of number of vehicle passenger car per mile per lane. Yes, you see different lines because on the right-hand side shows different links being selected, and you can click and drag different links. I will show you a video later on. And then all the links will be selected and displayed by corresponding colors. You can also uncheck by clicking on the check mark to deem or display different type of links. Alright, let's take a look. This is a typical plot for density. In here you can see different type of links and showing different density levels at different time of the day. This is a speed plot. Again, for the sensor links that we selected, you can look at their speed profile over the entire day. And obviously some are freeway links with speed drops during the day. Some are arterial links that has consistently maintain a slower speed. Flow rate indicates the amount of vehicle being discharged out of the link. And so this is the flow rate again for the same set of links that you can see the flow rate at different time of the day for different links. Queue length is another indication for number of vehicles staying in the queue. Again, this is a display for the queue length in terms of number of vehicles over the entire 24-hour period. Next, I would like to show you a short video, give you an idea how a user will probably use this in DynuStudio. Take a look. Here is a cumulative plot and different type of plot that you can select from the pull-down menus. And so there's a long list of the link-based statistics that you can choose from, and for the sense of links. And many of the statistics has been discussed earlier in the previous slides. But it's fairly simple to use. You can look at this, select different type of links. These are all the links associated with the plot and the different curves. All right, let's go back to a system level link performance. There are outflow density and flow density, and the best way to describe this is that you can see all the performance at the entire network level, and the best way to see it is from an animation. So here we have 3 animations to show. The first one is outflows to show the entire volumes for the entire system, entire network, and the density, and the final is flow plus density. So here we display a network from Seattle, Bellevue. You can see on the right hand side, this is the play button of the animations, and flow rate is displayed by time of the day in terms of bandwidth. The wider the bandwidth is, the higher the volume it is, and the flow rate is carrying. And again, we're playing very fast. You can adjust the speed at which you like to play forward and backward of this. So this is the control animation control button where you can show result back and forward. You can also click and drag the result back and forth. Let's take a look at the density plot. Again, we use the same control to display density because density is one of the selection from the pull-down menu. Here the density is displayed in terms of different colors. The green color stands for free. Here again, this is early. Look at this clock. This is early in the morning. Now we are getting to 7, 8 o'clock into the morning peak hours. After 9, 10, traffic gets better. And midday there's a little more traffic. And then as we gradually get into the PM peak, you start to see that the congestion picks up again. And then you have system-wide congestion fairly severely in the day. And then after the PM peak hour, pretty much the traffic system congestion back to normal situations. The last one is flow plot density. So we use a bandwidth to show the flow. So from the bandwidth, you can see the flow rate. And then from the color, you can also see the traffic congestion pattern. The single plot would display 2 information altogether to allow a user to better understanding the congestion. So here you have a lot of volumes, but again, only when those areas start not only have high volume but also getting into severe congestions during the day. Some places has fairly high volume but still smooth flowing. That means that you have enough capacity to carry high volume. But in the afternoon, you can see some places here display very severe congestion with fairly high volumes. So it allows you to not only identify the choke points but also understand the interaction relationship between volume and density, which is typically the level of service. Next is an important capability of DynuStudio. Talk about scenario comparisons. When we evaluate a number of different comparisons, particularly for the before and after study, we want to know what happened. And a typical scenario is if you close a street, a bridge, then traffic has to divert. You want to know where they diverted to, and you want to know which scenario is causing more congestions. So we use 2 different type of colors. So let's take a look at the scenario comparison animation. I'll explain along the way. Again, we use the control. We select two scenarios. One is here, one is here. Now let me pause here. So this is a scenario where a bridge is closed. Then we have baseline case, and in this scenario case, we close the bridge. As a result of bridge closures, then traffic need to start using other roadway to cross. And this, you can tell that the red and green. So green is the difference between the baseline and the after scenario. If in the after scenario the volume drops, then you see green. And then the red color stands for the volume increases. So you see some places have volume drops, some places you have volume increase as a result of diversion. So that's how you read this video. So you can see that the green are areas where volume drops, and then red are area volume got increases. Fast forward to a Chicago scenario where a bridge in canal is closed, and then you also see the volume increase on two parallel bridges, and you can see this is volume decrease, and you can see more volume coming through the other two bridges. Here's just an example of how you can visually effectively understand the diversion as a result of scenario comparison. So everything we have seen so far are providing information on a link basis, whether visualizing based on individual links or for the entire network. From time to time, we want to know the performance of the entire corridor, which consists of multiple links in one direction. We want to know the travel time from one end of the corridor to the other end, or average speed, or we want to know the heat map. The heat map is a very important way of seeing the congestion in space and time. The most important part, and then finally the very powerful way of looking at the corridor performance at the regional base is the travel time contour. We'll describe them one by one. Here is a way you can tag a sequence of links to form an entire corridor. And then we can plot the travel time and average speed for that entire corridor for the entire day. Okay, so this is the eastbound and the westbound, and then these are all the links consist of that, comprising that corridor. So that's a very powerful way of seeing the travel speed, average speed for the entire corridor. Heat map is also a very important way of showing congestions, and heat map is typically a two-dimensional view. So this axis is time, this is a distance by two different directions. This is showing that, for example, at this time, 7 to 9 o'clock, this is a corridor, right, from this side to this side, going from here to here. At the 7 to 9, this side and this side exhibit severe congestions, and there are some shock waves and congestions in the slow drop in a long way. And then during the midday, everything seems to be fine. In the afternoon, not too bad. If you look at the other directions, again, the heat map allows you to see in the other direction there's not much traffic in the morning, and then there's a little bit congestion in the afternoon. So heat map is really a very powerful way of seeing congestion happening in space and time along the corridor and over the entire day. From time to time, we want to know how fast the contour, travel time contour is a typical way for us to look at the travel time from an origin. And you use different color to describe how far can you go within certain time limit. For example, this is the count. This is, for example, this is 1 minute, 2 minute, 3 minute, 5 minute, 10 minutes. So this is why we describe that from the downtown CBD, because now it's congested. From downtown you can go this far within 15 minutes in all directions. Okay, so contour will also give you a sense of directions. The farther you can go in that direction, the less congestion you have. Then if we look at the AM peak, right, your contour, the shape of the contour changes and it can give you a sense of the congestion. This contour become much smaller, indicating that for the same amount of time you cannot go as far due to congestions. So when you compare the contour for the same area, same focal point between AM peak, PM peak, and off-peak hours, you have very good sense of congestion in directions, in which direction. So here is not just a corridor anymore. This is a area-wide view of congestion in all directions. So you can see in this case, AM off-peak and peak PM peak is not so much different, but you see a big difference in the shape in the AM peak. And then obviously it looks like this area is more congested in the AM peak, causing the contour to shrink a little bit more toward this direction. So again, this is a very powerful way of visualizing DynusT simulation results using travel time contour. Now, there are many ways to really deep dive and drill into a lot of detail and be able to visualize trajectories. And depending on the needs, sometimes we don't necessarily use trajectory animation just because typically it's a little more computationally intensive. But here, let's go through some of the capabilities that DynuStudio has. Vehicle animations. So DynusT is a mesoscopic simulation model, but it simulates individual vehicles and following a micro-like anisotropic mesoscopic simulations, which is published in Transportation Research Part B. And when you start to visualize vehicles, and you can start to realize, hey, I can really also see congestion and bunching, platooning as a result of from the animation. That's pretty visually powerful. Let's do a fast forward. All right, it's not showing some part of the video not showing, but here you got an idea that different color here is SOV, single occupancy vehicle, HOV, a truck. So you can actually show, you can change the color, so it allows you to actually see different vehicle categories in the animations. Vehicle animation compare. So we can bring up two scenarios in the screen and take two partitions of the main screen, and we can display both scenarios side by side if you really want to have a way of comparing both. Okay, and you can play, you can pause, and then you can compare the scenario. I don't typically do that a lot because it's a lot of information, but again, for whatever reason, you need to do that. This is a fairly powerful way to show that. Slot link analysis is a fairly powerful way of showing for a link of your choice how many cars are coming from, going to, where did they come from, where did they go to, and that's the purpose of slot link analysis. And you can see that these are actually individuals, vehicle trajectories. We are showing an animation of trajectories going through this bridge. At the same time, we also show the volume, okay, all the volumes by the bandwidth, but individual lines are actually the animation of vehicle crossing the bridge at different time. So you can see that give you a sense of where do they come from, where to go to for those people who use this bridge. And this is a very important way of showing the impact of a work zone or a closure. Sometimes your client may be asking, okay, if I close this bridge, what would happen? And who will be impacted? And that's a very powerful way of answering that questions. Selecting analysis with desired lines, and here is similar ideas, but really not only showing the trajectory, but show the OD. So desired line usually is a major OD pairs, and we use this to say, okay, for this link of selection, what are amount of OD that actually use the link of your choice, and that gives you a different sense from a demand standpoint, give you an idea about the demand. And that's a different way of visualizing the information. All right, finally, departure time and arrival temporal profiles. This is kind of system view. Give you a sense of delay and how do they arrive, how do they leave, and how do they arrive. So in this example, departure profile is shown in terms of the red line. This is how vehicles are departing by the hours. And then arrival profile, again, these are vehicles are arriving by the hours, and there's a shift. And usually the typical shift stands for how amount of time they stay in the system. So here, for example, here there's a large shift. Some people departing here doesn't really get a ride until later time. And this is usually because a larger delay and in congestion in the system. You can also correlate that with the average delay information by the hour. So you can see from from here 3 to 5 o'clock, and there are a lot of delay in this case, and then you see also a lot of shift in the arrival curve. All right, finally, we can also export the information to Google Earth mapping, and this is a very powerful and interesting way of showing the results. All the results can be exported to Google Earth, and we can render and generate the 3D to show the result very quickly. Here is the 3D view of the volume on the major arterials or freeways. So it's very easy to see the volume by the height of these bars. This is another way to show the demand, arrival and the demand of the city by different zones. So you can see that in the morning peak hours, a lot of demand. There's a very high bar in this area that indicating a lot of demand into the downtown CBDs. And again, all this can be quickly, fairly easily generated in Google Earth. With that, I summarize the basic mapping and visualization capability in DynusT and DynuStudio. Thank you.